Hello and welcome guys to the third part of circles where we are going to discuss theorems and solve sums based on the tangent and chord properties of circles. In the previous parts we have already discussed the angle properties and the cyclic properties of circles. So if you haven't watched those videos yet, go watch them. The link to those videos will be in the description box below. Watch this video till the end, and if you like it, do hit the thumbs up button. Share this video with your friends and subscribe to EduCeption if you haven't. Also, press the bell icon to get notified of all our videos. Without further ado, let's begin. First, let me tell you what a chord and what a tangent is. In the first part, we have already discussed what a chord is. A straight line joining any 2 points on a circle is called a chord. So what is that? Say we have a circle, a point A on the circle and a point B on the circle. A straight line joining point A and point B is called a chord of the circle. Say we have a point X over here and a point Y over here. A straight line joining point XY is called a chord. So basically a straight line that joins any 2 points on a circle is called a chord. Now what is a tangent? A straight line that touches a circle at only a single point is called a tangent to the circle. So what is that? Say we have a straight line like this that touches the circle at only a single point, say P. Then this straight line is a tangent to the circle. Let's call the straight line as T. Then T is a tangent to the circle touching at point P. And this point P is called the point of contact. Okay? Now, a tangent does not touch a circle at more than 1 point. It only touches a circle at a single point, and that point is called the point of contact. So remember all these things properly. Now that we are done with what is a chord and what is a tangent, let's move on to the theorems. We have the first theorem, that is the tangent at any point of a circle and the radius through the point are perpendicular to each other. What is that? Say we have a circle and a tangent T with the point of contact at P and the center of the circle at O. The theorem says the tangent at any point of a circle and the radius through the point are perpendicular to each other. So as I told you, we have the tangent T and the point of contact at P. So if I draw a radius like this through P, the radius will be perpendicular to the tangent. This is what this theorem is trying to say. Now this is true for any point on the circle. Say we have a tangent like this which touches the circle at point Q. If I draw a radius through the point Q, then the radius will be perpendicular to the tangent. Say the tangent is T1, then T1 will be perpendicular to the radius OQ. It's very simple, try to understand it properly. Now we move on to the next theorem. Moving on to the second theorem. If two tangents are drawn from an external point to a circle, then the lengths of the tangent are equal. It's very simple. Say we have a circle and two tangents are drawn to the circle from the same external point P. Then we get PA as the tangent to the circle and PB also a tangent to the circle. According to the theorem, the length of PA will be equal to the length of PB. So we get length of PA is equal to length of PB. So this is what this theorem is trying to say. Over here we get two more important results. What are they? Say we have a figure like this where we have a circle and two tangents are drawn to the circle from the same external point P. Then this angle, that means angle AOP, will be equal to this angle, that means angle BOP. And the second result, that this angle, that means angle BPO, will be equal to this angle, that means angle APO. So let me write it down. We get angle AOP will be equal to angle BOP, and angle APO will be equal to angle BPO. So we get three results, number 1, number 2 and number 3. You have to remember all these three results properly. Now we move on to the next theorem. Moving on to the next theorem. If a line touches a circle and from the point of contact a chord is drawn, the angle between the tangent and the chord is equal to the angle in the corresponding alternate segment. What does this mean? Say we have a circle and we have drawn a tangent to the circle x, y, and the point of contact is P. According to the theorem, if a line touches a circle and from the point of contact a chord is drawn, you can see that tangent xy is touching the circle at P. So P is the point of contact, and from P a chord is drawn. Say AP is the chord. Then the angle between the tangent and the chord is equal to the angle in the corresponding alternate segment. Now the chord AP is dividing the circle into two segments, the major segment and the minor segment, and say the chord is subtending an angle at the circumference at B. Then according to the theorem, the angle between the tangent and the chord will be equal to the angle in the corresponding alternate segment. So basically we will have the angle between the tangent and the chord. So this angle over here, that means angle APY, this will be equal to the angle in the corresponding alternate segment. The corresponding alternate segment is this segment, so this angle will be equal to this angle. That means angle APY will be equal to angle ABP. So this is what this theorem is trying to say. Let me explain it to you one more time. Say we have a circle and we have drawn a tangent to the circle xy and the point of contact is P. From the point of contact we are drawing a chord, say to A. So AP is a chord of the circle. Now the chord divides the circle into two segments, the major segment and the minor segment, and the theorem says the angle between the tangent and the chord is equal to the angle in the corresponding alternate segment. Now the chord and the tangent makes an angle, this, which is angle APY, and according to this theorem, this angle will be equal to the angle in the corresponding alternate segment, that means this angle over here. So we get angle APY is equal to angle ABP, as simple as that. Now we move on to the next theorem. Moving on to the next theorem. If two chords of a circle intersect internally or externally, then the products of the lengths of segments are equal. What does this mean? You can see we have two figures on the board, figure 1 and figure 2. Let's begin with figure 1. In figure 1 we have a circle and two chords of the circle, chord AB and chord CD. Both these chords are intersecting at a point P. That means these chords are intersecting internally. You can see the point P, that means the point of intersection is inside the circle, so they are intersecting internally. That is what it means. Now the theorem says the products of the lengths of segments are equal. We can see for chord AB we get two segments. First of all this one, which is PA, and secondly this one, which is PB. For chord CD we have two segments. First is this, that is PC, and the second is this, that is PD. So according to the theorem we will have the length of PA into the length of PB will be equal to the length of PC into the length of PD. So this is what this theorem is saying. Now we move on to the second figure. In the second figure we have a circle and two chords, chord AB and chord CD. Now both these chords are intersecting at the point P. So that means these chords are intersecting externally. You can see that point P, that means the point of intersection, is outside the circle. So they are intersecting externally. Okay. Now over here for the line AP we get two segments. The first one is PA and the second one is PB. For the line CP we get two segments. The first one is PC and the second one is PD. So according to the theorem we will have the length of PA into the length of PB will be equal to the length of PC into the length of PD. So basically we get the same thing. Now over here in figure 2 a lot of students get confused. Instead of this they write AB into PB is equal to CD into PD. But this is not correct. Don't write this. This is correct. So keep it in mind. Now we'll move on to the next theorem. Moving on to the next theorem. If a chord and a tangent intersect externally, then the product of the lengths of the segments of the chord is equal to the square of the length of the tangent from the point of contact to the point of intersection. Now this theorem may seem very big and complicated, but it is not. It is very simple. Say we have a circle, we have a tangent PT and we have a chord AB. The chord and the tangent intersect externally at the point P. Then PT square, that means the length of the tangent squared, will be equal to the product of the lengths of the segment of the chord. So over here for the chord AB we have two segments. The first one is PA and the second one is PB. So PT square will be equal to PA into PB. This is what this theorem is saying. Now this is very important, so keep it in mind. Now that we are done with the theorems, we will move on to the sums. Let's begin with sum number 1. In the adjoining figure, O is the center of the circle and SP is a tangent. If angle SRT is equal to 65 degree, you have to find the values of X, Y and Z. This is the given figure. O is the center of the circle, SP is a tangent to the circle and angle SRT is given 65 degree. We have to find X, Y and Z. So let's begin. First we find X. Now we know that SP is a tangent to the circle with point of contact at S, and through S a radius is drawn OS. The first theorem that we studied in today's video was the tangent drawn at any point on the circle and the radius through that point are perpendicular to each other. That means the tangent SP will be perpendicular to the radius OS. So this angle over here is 90 degree. So I'll write angle TSP is equal to 90 degree. And beside it I'll write the theorem that I used, that is the tangent drawn at any point on the circle and the radius through that point are perpendicular to each other. Now check out triangle TSR. In triangle TSR, we know two angles, 90 degree over here and 65 degree over here. So we can easily calculate X over here because we know the sum of all three angles of a triangle is 180 degree. So let's do it. So in triangle TSR, we have angle TSR plus angle SRT plus X is equal to 180 degree. So we get X is equal to 180 degree minus 90 degree minus 65 degree. Therefore X is equal to 25 degree. So we get our first answer that X is 25 degree. In the second one we have to find Y. Now we can see that SQ is an arc of the circle and SQ is subtending an angle at the center O and it is also subtending an angle at the circumference at T. So we know from the theorem from the first video that the angle subtended by an arc at the center is double the angle subtended by it at the circumference. So over here angle SOQ, that means Y, will be double angle STQ, that means X. So we will have Y is equal to twice X Therefore y is equal to 2 into 25 degree. So y is equal to 50 degree. So y is 50 degree. And beside it I'll write the theorem that I used, that the angle subtended by an arc at the center is double the angle subtended by it at the circumference. So we get x 25 degree and y 50 degree. So this is 50 degree. Finally we have to calculate z. Now check out triangle OSP. In triangle OSP, we know one angle 90 degree and another angle 50 degree. So we can easily calculate Z, as we know the sum of all three angles of a triangle is 180 degree. So I'll do that. So in triangle OSP, we have angle SOP plus angle OSP plus Z is equal to 180 degree. And beside it I'll write the sum of all three angles of a triangle is 180 degree. So we get Z is equal to 180 degree minus 50 degree minus 90 degree. So Z is equal to 90 minus 50, that's 40 degree. So we get our third answer, that Z is 40 degree. So X is 25 degree, Y is 50 degree and Z is 40 degree. Now we move on to the next question. Let's begin with sum number 2. In the given circle with center O, angle ABC is equal to 100 degree, angle ACD is equal to 40 degree and CT is a tangent to the circle at C. You have to find number 1 angle ADC, number 2 angle CAD and number 3 angle DCT. This is the given figure. O is the center of the circle, angle ABC is given 100 degree, angle ACD is given 40 degree, CT is a tangent to the circle at the point C. That means C is the point of contact. So let's begin. In the first one we have to calculate angle ADC. What's that? Angle ADC, that means this angle over here. Now we can see that ABCD is a cyclic quadrilateral. In the second part we studied the opposite angles of a cyclic quadrilateral are supplementary. We can see that angle B and angle D are opposite angles of a cyclic quadrilateral. That means angle B and angle D will be supplementary to each other, which basically means that angle ABC plus angle ADC will be 180 degree, and using that we can easily calculate angle ADC. So let's do that. So number 1, angle ADC plus angle ABC will be 180 degree, and beside it I'll write the theorem that I use, which is the opposite angles of a cyclic quadrilateral are supplementary. Then I get that angle ADC is equal to 180 degree minus 100 degree. That means angle ADC is equal to 80 degree. So we get our first answer, that angle ADC is 80 degree. So this over here is 80 degree. In the second one we have to calculate angle CAD. What's that? Angle CAD. That means this angle over here. Now we can see in triangle ACD we know two angles, 40 degree over here and 80 degree over here. So we can easily calculate the third angle, that means angle CAD. As we know, the sum of all three angles of a triangle is 180 degree. So let's do that. So number 2, in triangle ACD, angle CAD plus angle ADC plus angle ACD will be equal to 180 degree. And beside it I'll write that the sum of all three angles of a triangle is 180 degree. So we get angle CAD is equal to 180 degree minus 80 degree minus 40 degree. That means angle CAD is equal to 60 degree. So we get our second answer, that angle CAD is 60 degree. So CAD, this angle is 60 degree. In the third one we have to find angle DCT. So that is DCT. that means this angle over here. Now the third theorem that we studied in today's video was the alternate segment theorem. Now we know that CT is a tangent to the circle and the point of contact is C. From C a chord is drawn to D, so CD is a chord. Now we can see that CD subtends an angle at the circumference at A, which is angle CAD. Now according to the theorem, the angle between the chord and the tangent will be equal to the angle in the corresponding opposite segment. That means this angle over here, that is angle DCT, will be equal to angle CAD. So if this is 60 degree, this will also be 60 degree. So I'll write number 3, angle DCT is equal to angle CAD, that is angle DCT is equal to 60 degree. And beside it I'll write the theorem that I used, which is the alternate segment theorem. So we get our third answer, that angle DCT is 60 degree. Now we move on to the next question. Moving on to sum number 3. In the adjoining figure, chord AB and chord CD of a circle meet at P. PT is a tangent to the circle at T. CD is equal to 7.8 cm, PD is equal to 5 cm, PB is equal to 4 cm. You have to find number 1 AB and number 2 the length of the tangent PT. This is the given figure. AB is a chord of the circle, CD is a chord of the circle, and both the chords meet at P. That means they intersect externally. And PT is a tangent to the circle at T. So let's begin. In the first one we have to find AB. Now we know that if two chords of a circle intersect externally, then PA into PB will be equal to PC into PD. So let's do that. So number 1, PA into PB is equal to PC into PD. Now let me write down the things that are given. CD is equal to 7.8 cm, PD is equal to 5 cm, and PB is equal to 4 cm. Now CD is given and PD is given. What is CD? This length is CD, and what is PD? This length is PD. So if we add up both the lengths, we will get the length of PC. So let's do that. So PC is equal to CD plus PD, which is equal to 7.8 plus 5 centimeter, which is 12.8 centimeter. So we know PD, we know PB, we know PC. So we have to calculate PA. So let's do that. So we have PA is equal to PC into PD by PB. So PA is equal to 12.8 into 5 divided by 4. So we get 10 over here, 2s are 64 and 4 16s are 64. So PA is equal to 16 centimeter. But we need to find AB. Now we know PA, that means the complete length, and we know PB, that means this length. So AB will be equal to the complete length PA minus PB. So let's do that. So AB is equal to PA minus PB, which is 16 minus 4 centimeter, which is 12 centimeter. So we get AB as 12 centimeter. In the second one, we have to calculate the length of the tangent PT. Now we know that if a tangent and a chord intersect externally, then PT square will be equal to PA into PB. So let's do that. So number 2, PT square will be equal to PA into PB. So we get PT square is equal to PA, that's 16, into PB, that's 4. So PT square is equal to 64. Therefore PT is equal to 8 centimeter. So we get the length of the tangent PT as 8 centimeter. Simple. Now with the end of this sum, I will end this video over here. and this video is the last part of circles. Now you have a lot of sums in your book, so try to do all the sums, and if you face any problems, you can comment down below or write to us at eduception01@gmail.com. New videos on EduCeption are coming very soon, so stay tuned. Until then, this is Rishi on behalf of EduCeption signing off.